Milani, grade 10, don't miss the mark. We see the groups from 10 to 20, keeping it sharp. Frequency is 6, don't just use the 10 or the 20. Calculate the midpoint, that's where the wisdom is plenty. Upper plus lower, then divide by 2. That 15 is the midpoint, that's what you gotta do. Misconception number 1, don't use the boundary. Midpoint is the key to unlock the treasury. Estimated, meanwhile, outre, calculated. Midpoint times frequency, then sum it up, add it up. Divide by the total frequency, see, keep your head up. That's the mean mark. A Sunday, let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Now look at part B, where the median hides. Don't just choose the biggest frequency, that's where the error slides. Frequency 14 is big, but that's not the median location. We need the middle position for this statistical station. Total frequency is 40, divided by 2. The 20 hit position is waiting for you. Calculate a Q middle 6, then 20, then 32. That 20 student is in the 20-30 group. It's true. Estimated, meanwhile, outre, calculated. Midpoint times frequency, then sum it up, add it up. Divide by the total frequency, see, keep your head up. That's the mean mark. A Sunday, let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Remember the cumulative sum. No more misconceptions, grade 10, the work is done. Estimated, meanwhile, frequency, see, keep your head up. That's the mean mark. A Sunday, let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Class dismissed, sharp, sharp. Grade 10, you got this. Azambege.
Welcome, grade 10s. We are going to be doing the test that we expect grade 10s to be writing. I think it's going to be the first test, term 3. Luanze will correct us. So there's a term test. I think they write 2 in grade 10. So there's the first one, which has the structure. It will just share to us what is it that we're planning to do on the structure of the question paper. How does it look like? So what is it that we're going to be focusing in? So if you are in grade 10 and then you are preparing for your term test, these are the things that you should be looking for.
Okay, should I take him through everything?
What is the structure? No, like the structure of the question paper, the one that I send you to say, we should have stats, how many marks, more or less.
Okay, so then here's, let me go to the test. I should view it.
Yeah.
So it's mathematics.
Yeah.
Okay. So the test is September paper, grade 10.
So
50 marks.
Sponsored by Funda Flow.
Sponsored by Funda Flow.
It comes from Funda Flow. This
The daily dose of mathematics sponsored by Funda Flow.
Sure, sure.
Great. This is how the seal or the
question paper.
The question paper is gonna look like.
Structured. Okay.
Yeah.
So we have the instructions there. What are the important instructions that you can highlight? Because they say if you don't follow the instructions, you can't play the game.
Yep.
So what are the instructions that we have there?
First one says national. No. Says the question paper consists of 4 questions.
Okay. So we expect to have question 1, question 2, question 3, question 4. Sure. Yeah.
Okay. It says answer all the questions.
So we're going to be attempting to answer all the questions that were given here. Yeah.
And then it says clearly show all calculations, diagrams, graphs, etc. that you have used to determine your answers.
Your answers.
Yeah.
So we have the following instructions, and then what is our question 1 according to this question paper?
Question 1. Let's welcome everyone in the chat.
Okay.
Welcome. We are the daily dose of mathematics sponsored by Funda Flow.
Sure.
Remember, if you're looking forward to use Funda Flow, you can get the link in the comments.
So send that code there, that gives people free credits when they sign up. Just put that one on the link there so that they can get extra 5 credits when they sign up.
Or should I send them that one?
Yeah, send them that one.
Okay.
You can send it with that. Have you sent the first one? Or you're still going to send
I've
it?
already sent them.
Okay.
It's in the comment. But then I'll send it one.
Yeah, send that one if a person just looks in now. So guys, how it's going to work, this thing here today, we are planning to, we will see how far we go with the test, but what we're going to try to do is that we're going to prepare you thorough for that test. So what we will do is that we will do a question. Once after doing the question, we will put it on Funda Flow to generate a similar question, and then we'll expect you to attempt it. So we'll be playing songs while we do that, and then we'll check the grading on Funda Flow, and then we'll decide if people are fine or they're not fine. So if you are still not fine, then we might have to go back again, because when it comes to stats, I think we've been doing stats for the past 2 weeks or so now.
Yeah.
And then I requested which we start on trigonometry today.
Yeah, we should do trigonometry
We
today.
start on trig.
Yeah.
Yeah, so but the way it's going to work is that we'll show the example that we have. Okay? From the example, we'll take that example and then we'll just create a test on that one, and then just call it trigonometry one.
Okay.
And then it will be just a short test, and then we'll expect chat to be able to submit that one so that we see if they understand what is it that we're talking about.
Okay, so then right now I'm still putting the thing in my
The one
comments.
of the comments, okay.
Yeah, you can use that bargain the link to get free 5 credits.
Okay. It's ready.
I'm still processing, but then we can continue while I'm still processing the thing.
Okay. Yeah, so that's the structure of this question paper, guys. That's what we're going to be having today.
Okay, it's question 1.
Yeah, it's question 1, statistics, no?
Yeah, question 2. Question 2 it's trigonometry.
It's trigonometry, question 2. Okay, question 3.
Question 3 it's trigonometry curves.
It's the trigonometry. Guys, this one is one of the most important topics because you only do it in grade 10. Grade 12, we don't teach trigonometric graphs, no? And then they assess them. In grade 11, they are there, but they don't give them enough time. So the only time you're going to get time to do trigonometric graphs is in grade 10.
Okay.
Yeah, so it's very important for us to be able to do that one. And then what is the last one?
Okay, the last one it's
Functions.
exponent and hyperbola functions.
Exponents and hyperbolic function, okay. You can play the song while you're busy with whatever it is that you're busy with it, so that we can start together.
Okay, let me play the song. Stick with us, guys. We're still doing something.
What's the challenge? The code is there. Already sent it to us. Try to copy it.
Yeah, welcome back. We are back again.
Okay.
Okay, so today we're dealing with question 2.
So we're starting with question 2.
Yep.
Okay, which is trigonometry.
Yes, trigonometry.
Okay. Now, remember, guys, at Funda Flow, we have a chatbot which can assist you in this. Let's say you don't know trigonometry. What we're going to do now is to take this question and put it in our mini lesson so that we can be guided with what is this trigonometry? What are the things that learners need to remember? Remember, learners need to know something about soccer.
Yep.
But what I'm also trying to emphasize is that a person doesn't need me to learn the trigonometry. Maybe they can need me when they say, I don't understand something.
Yep.
So if we check this and then just put it on our Funda Flow.
Okay, mini lesson.
Yeah, let's put it on a mini lesson. Let's get the mini lesson to check what are the important things that learners need to know. Now, primarily is that you need to know, guys. You need to know how to use your calculator. That one is very important. And then, in fact, while the guy is busy generating, then we're going to take an opportunity to show people how to use their calculator. Your calculator should be in degrees. So you should always check that your calculator is in degrees if you're going to be doing trigonometry. So whatever it is that you're doing, you start with your calculator. And then you don't borrow a calculator, guys, that you're going to be using in the exam for the first time. So you should never do that.
You don't borrow a calculator.
Yeah. So your calculator should be you, and then you should be your calculator. You should know each other. You know it. How does it behave?
Yeah. Okay, so let's show them how to use the calculator while our mini lesson is still processing the thing.
Yeah. Okay. So on your calculator, on top there, there are different setups that this calculator they can put it in. There's this one that it usually falls in. I don't know what happens. It's R. It's rand. It should supposed to say degree. So you should always make sure with your calculator, if you're going to be working with trigonometry, it should be in degrees. So can you see those things that I'm talking about?
Yeah, this D.
This thing. Yeah. Now, how does this thing change? It changes on setup. Now, let's just show them which way do they change it if their calculator is not fine. So you say shift
Shift mode.
Yeah.
And then
Setup.
there's 1 mid turn, 2 lean turn, and then 3 decrease.
Yeah.
Press
4 8.
3. I've already pressed 3.
Or you've already pressed 3. Yeah. So if your calculator is saying R on top there, well, now you should change it and just press 3 so that you can get the degrees. That is the first thing that we need to know. And then the other thing that we should know is that we should know something about trig ratios. In fact, we should know something. What is a ratio? Let me just ask you that. What is the ratio?
1:2.
It's 1:2. It has something to do with division.
Yeah.
So we have something called a trigonometric ratio.
Yep.
So it means which we are going to be comparing two things in terms of a certain trigonometric ratio.
Yep.
Now, the famous one that we have that we usually use is the one that we call Socraton. It's S-O. It's S-O. No?
So let me go to my smart notebook.
Smart notebook, okay.
Okay, say it's say something like
S-O.
S-O-H
C.
C
A.
A
H. Soccer.
soccer.
Yeah.
And then there's tour.
And then there's Toa. T-O-A.
So what does those things mean?
What does those things mean? It's very important they do. Because once we understand these things, we're not going to have a problem. Now, this is how we define trig ratios in a right angle triangle. Very important.
In a right angle triangle.
Yeah, they don't work if you are not in a right angle triangle. Maybe the other question that we should ask chat, what is a right angle triangle? How do we know something is a right angle triangle? If they can give us that one, what is a right angle triangle?
Anyone in chat can tell us that. Somebody.
What is this right angle triangle?
Anybody? Are they going to tell us? Or should we continue?
Let's wait for them.
5 minutes. Ticking tempo.
Yeah, we you remember you used to have that one with the wheel. We should also have that timer.
The wheel timer thing.
Yeah, but tonight it should tick like we should put that thing there. When we give them time, let's say it's 60 minutes or and then after 60 minutes then we move on. We should just put something like that there.
Okay. Why not just doing?
Huh? Oh.
Will I do it forever? I don't think so.
60 minutes.
Somebody, anybody, don't let me hang in what I'm doing forever. You should.
But we have people in chat.
Yeah, we have people in chat.
So we're looking for what is this right angle triangle?
Right angle triangle. I can just give them the answer.
Okay, what is a right angle triangle?
Yeah, I can't give them the answer per se, but then I know what are the features of right angle triangle.
So you can't tell us what is this right angle triangle. But
I can't.
You know when you see it. This one is a right angle.
Yeah, this one is a right angle triangle.
Okay.
A right angle triangle is an angle of 90 degrees.
So it's a triangle, no?
Yeah, it's a triangle that is in its shape form.
It's a triangle which has an angle
of 90 degrees.
90 degrees. No? It has one side of a triangle perpendicular to one side of another triangle. No?
Yeah.
And then on the 90 degrees here is always opposite to something. You see this 90 degrees. When we say something opposite, we mean it's looking at. Okay?
Yeah.
This 90 here is looking at someone. This line, this big line here, this thing here, you can do that. On there.
So looking at the steep slope string.
Yeah, so I think we say a right angle triangle. Basically, a triangle is something that has three sides. So we have two sides which are going to be perpendicular to each other. Then the other one is just going to connect these two which are perpendicular to each other. That's a right angle triangle.
Yeah.
So if you want to draw a right angle triangle, basically the simplest thing for you to do is to say, okay, let me say I have A on top again. And then I have B on the bottom. So this is the line. This is the first line. Okay?
Yeah.
This one is not a triangle. It's just one line. Okay? And then from B, I can make it to be perpendicular, and then I have BC. You see now. Now B is my angle, which is going to be 90 degrees.
Okay, yeah.
So now these are two sides. It's still not a triangle. So how do we form a triangle? Then we're going to connect the two perpendicular lines.
Yeah.
So if we connect them now, we're going to have a longer one. It's longer than the two of them.
Okay.
Yeah. So this one, which is longer than all of them, we are going to start by naming it, because if we can name that one, the other ones it's going to be simple. No? So when we define this thing here, we say we have 90. Okay?
Yeah.
Now 90 is going to be looking at this person here who just connected these two perpendicular lines. And then because 90 is looking at that person, so you should start there. is looking at this person called a hypotenuse side.
A hypotenuse side.
Yeah, it's a hype.
For me to cram this thing while I was still at school, I was like, okay, a person who's standing in front of, okay, the person who's, if there's not this, we are given a right angle triangle again. A person who's who's nameling at an incline, is it an incline? Who's nameling at an angle? Yeah, a person who's nameling at an angle, it's hypotenuse. If I'm given a right angle triangle, because I do know a right angle triangle has 90. So a person who's climbing up at an angle is hypotenuse.
Okay, it's a good definition, but it lacks something, because remember, a right angle triangle is not always going to be given horizontal. They can change it. The 90 doesn't have to be on the horizontal plane. So if it's not on the horizontal plane, it's no longer going to be nameling anymore.
Okay.
So it lacks some.
Oh, I was like, oh, can they give us a right angle triangle in another different form? Secant.
Yeah, remember, you see this first instant that we have here. We have the 90 in the horizontal plane.
Yeah.
So 90 doesn't have always to be on the horizontal plane. 90 can also be, let's say, which we can put it maybe here.
Yeah.
I want to put it on the vertical plane. Then let me put. It's going to be it's horizontal and vertical.
Yeah.
Okay. So if we have vertical and then we have the horizontal line and then they form.
Yeah.
And then now we can have another instant like this. So this one is it nameling?
It's touring. It's touring at an angle.
The other one is climbing.
The other one is climbing. Then the other one is
going down.
Decrease.
Okay.
Decrease down. Yeah.
Okay. Now what I will say too is that, like, when you see 90, you see this square thing. This is 90. Remember how to define 90 10. We say the square thing is 90.
Okay.
So I'm simply going to put eyes there, and say this person is looking. So it's like a face. The 90 to me is just a face. And then I'll ask, which this 90 is looking at who? Whoever is looking at.
Okay, this thing looks funny now. I made an earring. Now I made two eyes in parking. The other one are outside of the earring. Now it looks like a parking, a smiling face.
Okay.
Smiling face with a V.
Yeah. So it just says, which if you say the one which is being climbed or being unclimbed, it's going to be our hypotenuse side.
Yeah.
Yeah. Why is this important, guys? It's important for us to be able to define these things here without any trig ratio. Then we'll come and use the trig ratios. Hypotenuse side doesn't need any trigonometric ratio. It exists on its own. Then even here we have the angles. Remember the one that you have here. You have B as 90 degrees.
Yeah.
You have angle C.
Angle C.
Which is an angle of elevation.
Angle of elevation.
Yeah, it's an angle that you, when you are, it's an angle when you are looking from the bottom to the top. That one we call it an angle of elevation.
Angle of elevation.
Yeah, it's elevating. It's going up.
Elevating, escalating.
Yeah, and then here on top, here you see this one. If you look, if you are from a person, let's say you stay in an upstairs,
yeah.
When you're looking down, that one is an angle of depression. So you're looking downwards. So we have two types of angles. We can have an angle of elevation, you're looking upwards. And then the other one is a person from the ground looking upwards. It's elevation.
Okay.
Then there's a person from the height, and then they're looking downwards. That one is an angle of depression.
Okay, yeah.
It's fine again.
That's fine.
So why this then? We want to define something here. We want to talk about angle C. Again, this is B. B is 90. It's fine.
Yeah.
B. What has B gave us? B is the person who defined our hypotenuse, because we needed to know the hypotenuse. Once we know the hypotenuse, then we can then go and talk about the two other angles that are still remaining.
Yeah.
So the first angle that we have, you say it's C. We say C is what? It's an angle of elevation. It's fine. I get that one.
Yes, it's an angle of elevation.
Now C, you see C.
Yeah.
The capital letter C, you can still put him inside, like just inside here. Now we are making him to be an angle. Instead of him being a side, it's going to be an angle now. So we just put him inside. Now remember, when we are dealing with trigonometry, we can use such angles as theta, alpha, all those different angles.
Yeah.
So C is an angle. Now C has two sides that we haven't used, because we have the hypotenuse side. In relation to C now, there are two sides that we haven't used. If we think of it this way, this thing, I usually say to you, you see me and you the way we are seated. No?
Yeah.
It's just people can't see us. If you use me as a frame of reference, you are on my right hand side. If you use me as a frame of reference, you are on my right hand side. But if now we use you as a frame of reference, it's going to change. You can't say Mina, like whenever you're going to say Mina, I'm at your left hand side.
Yeah.
It's both of us were right. It's just good if you take me, if a person is observing from my standpoint, they're going to see things differently than a person who's observing from your point.
Yeah.
So if we observe this triangle from C, it's going to be different from the way we observe the triangle from A.
Okay.
It has to do with observations here.
Yeah.
So let's start with C. We're saying C is our frame of reference, which basically we're looking at everything according to C. How does C see things? I don't know if it makes sense. Chat, can you tell me if that makes sense? Because this one we need to grasp it. If we can't grasp this one, we're going to be in trouble.
You might make it as a person.
Huh?
As a person.
Yeah. Yeah, that person, yeah. We're going to look at things according to the person. Yeah, it's fine. Yeah, that one is fine.
So this person, when he's looking at this wall thing, that means the wall is, okay, he's facing this way. I don't know if, can I make the eyes nine?
Yeah. Like, again, the way we did, you remember, the way we did the 90 degrees, we just said this 90 degrees is looking there.
Yeah.
So even C is going to be looking at somewhere. Like, just say C is looking, is pointing at someone there.
Yeah.
And then if you ask me, who is still looking at? That's the question that we can ask. Who is opposite? Looking at is opposite.
Yeah.
So who is still looking at? If you put that arrow there that we did similar to the one that I 90.
He's looking at AP.
Yeah, he's looking at AP. The one. So in relation to C, very important. And this is according to C. It's not true with everyone. According to C, when C looks at AP, he will say, Marasi, like when C looks at AP, he says, that person is opposite to me.
It's opposite to me.
Yes. That's according to C. C says, when I look at AP, you're opposite to me.
Yeah.
But when C looks at BC, you see, like guys, you should remember something. I'm not talking about the hypotenuse side. Hypotenuse side, I've already defined it.
Yeah.
Doesn't interfere anymore. So when C, he has two. Again, let's go back. We have a triangle.
Yeah.
Triangle has three sides. First thing that we are going to do in our steps, we define the first one. We need to do away with the first one.
Yeah.
The first one that we are going to define first is the hypotenuse side. Why is that one? That one is because it comes with 9. So once we define that one, we're left with two people. These two people here, they can either be opposite or adjacent to the remaining angles that we even used.
Yeah.
So in relation to C, C he still has BC. Can you see BC?
Yeah.
But C is not looking at BC now. If we were to talk about it, can you see that? What will you say? How will C define BC? What will you think he will say? Yeah, so you just say it's next to me again.
Yeah.
Yeah, this person is just next to C. So there's a mathematical term that we use for that. We say with this person is adjacent, but it simply means next to.
Adjacent.
Yeah, it's adjacent to C.
Yeah.
It's adjacent. Yeah, well, in relation to C, this one is adjacent. So when we're defining it, I want you to define it this way. You will say with it's at C. It's adjacent to C. It's not adjacent this side. It's adjacent to one specific person who is C.
Okay.
Does it make sense?
Yeah.
And then we have this one here, AB. You want AB? AB is up to C. It's not opposite. It's opposite to only one person in this triangle. Who's that person? C. Now, it's like we can talk about him. A is going to see things differently than C because they're not in the same plane. Can you see that one? So how will A define AB? How will A define BC? That's what we're trying to find. So that we can use these things that they are saying. I haven't forgotten.
1 minute. Can I keep doing this? Can I keep doing this, or is it annoying?
No, you can do it. Yeah, it's fine. You can even search for a stopwatch now. While we are waiting for them, we play a song and then we wait for them. You search for a stopwatch that you can use.
Guys, what is A? What is A?
We're asking what in relation to A.
What in relation to A? What
is it
BC?
opposite or adjacent? That's what we're trying to get.
BC or AB?
AB. We're trying with AB.
Oh. In relation to A, what is AB? Stopwatch. I'm a stopwatch by myself.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Still, no one.
On YouTube, everyone run away. On YouTube, everyone run away. They're scared of questions. Always on YouTube, they're always running away.
Okay, let's check on TikTok, yeah?
TikTok, they didn't run away. They're still there, but then no one is answered. But then let's do it.
Let's do it. Yeah, in relation to AB, we will say A will say this person is what? Next to or opposite to?
It's opposite to.
A, what will A say according to AB? He will say, is it next to him or it's opposite him? Is he looking at it or it's just next to him?
He's looking at it.
So it's adjacent. So we'll say it's up adjacent to A. You know what? It's opposite to C, but it's adjacent to A.
Yeah, it's adjacent to A. Adjacent to A.
Yeah. Next.
Yes.
Then we can have A in relation to BC. What will you say? Is he looking at him or is just next to him also?
He's looking at him.
So we'll say with him, BC is opposite, is up A. Yeah, what is opposite A? It's fine, isn't it?
Yeah.
We have defined. Check if they're still back, those people, or they ran away. Why?
They ran away.
They
come. Maybe they'll come in a minute.
Put it there. They're still going to drink water, or they're still going to count.
They're going to drink water. Shout.
Okay. So now that we know that we can then go and define these things. We can say what is the structure. I wanted us to play even that mini lesson. So let's play the mini lesson while we wait for them. Maybe they will come back.
Okay, let's go to our mini lesson.
At the Funda Flow.
Yeah. Sponsoring.
At the Daily Dose of Mathematics.
Welcome to your math lesson. Let's break down the key concepts behind solving right-angled triangles using the Pythagorean theorem and trigonometry. 1 Core theory and rules. Rule 1, the Pythagorean theorem. In any right-angled triangle, the square of the length of the hypotenuse, the longest side, directly opposite the 90 degrees angle, is equal to the sum of the squares of the lengths of the other two sides. Formula, C2 equals A2 plus B2. Where C is the hypotenuse. A and B are the two legs forming the right angle. Rule 2, finding an angle using trigonometric ratios, so CAH TOA. To find a missing acute angle in a right-angled triangle when you know the lengths of the sides. 10, theta, equals opposite/adjacent. Opposite is the side directly across from the angle you are looking for. Adjacent is the side next to the angle you are looking for, that is not the hypotenuse. To find the angle itself, use the inverse tangent function on your calculator. Theta equals tan 1, opposite/adjacent. Dash. 2 Walkthrough example, mirror problem. Let's solve a similar problem together. In right-angled triangle PQR, angle Q equals 90 degrees, side PQ equals 5 centimeters, and side QR equals 12 centimeters. 1. Calculate the length of side PR. 2. Calculate the magnitude of angle P, correct to 2 decimal places, 12 centimeters. PR equals. Step-by-step solution. Step 1, find the length of side PR, hypotenuse. Using the Pythagorean theorem. PR2 equals PQ2 plus QR2. PR2 equals 52 plus 122. PR2 equals 25 plus 144. PR2 equals 169. PR equals square root 169. PR equals 13 centimeters. Step 2, find the magnitude of angle P. With respect to angle P, opposite side equals QR equals 12 centimeters. Adjacent side equals PQ equals 5 centimeters. Set up the tangent ratio. 10, P, equals opposite/adjacent. 10, P, equals 12/5. 10, p, equals 2.4. Now take the inverse tangent. P equals tan 1, 2.4. P 67.38 degrees. Dash. 3. Practice and self-check. Now you are ready to tackle your original problem. Use these guiding questions to work through it. 1 for part 2.1.1, which side is the hypotenuse in triangle ABC where angle B equals 90 degrees? Substitute AB equals 8 centimeters and BC equals 15 centimeters into the Pythagorean formula, AC2 equals AB2 plus BC2. What do you get when you take the square root? 2 for part 2.1.2, relative to angle A, which side is opposite, BC or AB? Which side is adjacent? Calculate the fraction opposite/adjacent and use tan 1 to find angle A rounded to 2 decimal places. Give it a try. What answers do you get for side AC and angle A?
Okay, so then we have something from Lwandle.
Okay.
Lwandle told us what he did question 2, but he can't sign up or log in to submit.
You must sign up. No?
Yeah, but then I can do it in my account.
You can do it, but you can send his work.
Like he already sent it.
Okay.
I can just upload it in my thing.
Okay, Lwandle, you give us permission to do your work. Let's see.
Do you give us permission, Lwandle? You can just say it in chat and we'll be waiting for you for the permission thing. You will give me credits if you got it total.
You got it?
You got it total, it will give me credits. And remember, everyone who's at chat, you can just do it and then you can WhatsApp us, send what you did, and then you can also sign up. I don't know why did Lwandle not be able to sign up?
Can you go and check the table? You don't have to show them. No?
Okay.
That seems to be the issue.
Let me show them the calculator.
Okay.
You should see the calculator whilst I'm busy. Okay, there's someone in the comments who said yes, you can.
You can what?
You can. I think it's Lwandle.
Oh, it's one. Okay.
Yeah.
So
thanks for liking the video, Nathan.
okay, so what we're going to do now is to take Lwandle's solution and then we're going to put it into the senior mark. Now, it is going to mark him only one question because he hasn't done on the question. It's going to penalize him for the other questions.
Yeah, it's going to penalize him for the other
So it's
question.
only going to mark him one question.
Yeah.
So Lwandle, these are not your marks. Now, this is not going to be a true reflection of your mark.
They're going to be the marks for question 2.
Yeah, it's just going to be marks for question 2.
Okay, so let's go back to our document thing. Our Funda Flow.
Yeah, our senior mark.
Senior mark of the year. This one is one of the best senior mark.
So if you hear them saying ETF Rahutu, you should know what they're talking about, Lwandle.
Yeah, it's Lwandle, not E.T. Frahout. Lwandle. This one is your brother. You may, Barky, tap the screen, you guys. Tap the screen while I'm playing the song and let's dance a little.
Mamelani, grade 10, don't miss the mark. We see the groups from 10 to 20, keeping it sharp. Frequency is 6, don't just use the 10 or the 20. Calculate the midpoint, that's where the wisdom is plenty. Upper plus lower, then divide by 2. That 15 is the midpoint, that's what you gotta do. Misconception number 1, don't use the boundary. Midpoint is the key to unlock the treasury. Estimated, meanwhile, Utois calculated. Midpoint times frequency, then sum it up, add it up. Divide by the total frequency, see, keep your head up. That's the mean mark. A someday, let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Now look at part B, where the median hides. Don't just choose the biggest frequency, that's where the error slides. Frequency 14 is big, but that's not the median location. We need the middle position for this statistical station. Total frequency is 40, divided by 2. The 20 hit position is waiting for you. Calculate a Q middle 6, then 20, then 32. That 20 student is in the 2030 group. It's true. Estimated, meanwhile, UTWA. Calculated. Midpoint times frequency, then sum it up. Add it up. Divide by the total frequency. See, keep your head up. That's the mean mark. A sunbathe, let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Remember the midpoint. Remember the total frequency. Remember the cumulative sum. No more misconceptions. Grade 10, the work is done. Estimated, meanwhile, UTWA. Calculated. Midpoint times frequency, then sum it up. Add it up. Divide by the total frequency. See, keep your head up. That's the mean mark. Someday, let's find the middle, where the median stays. Cumulative
Question
frequency
2.1
will guide us
marks.
through the maze.
3/3 Correct application of Pythagoras theorem to find AC equals 17 cm. Question 2.2.1 marks. 3/3 Good setup using tangent ratio to find BC equals 35,70 cm. Question 2.2.2 marks. 3/4 Correct trigonometric process to calculate length and final sum, though variable labeling could be clearer. Summary solid understanding of right-angled trigonometry and basic geometry.
Okay, Lwandle killed it.
Yeah, like our Funda Flow has seems to be improved. It marks him based on question 3, and then he said he rounded off to 2 decimal places because it didn't specify.
Oh,
Oh yeah, it didn't specify. Correct, Barking,
the rule.
the rule is the rule there? I think it's there.
Yeah, it's in maths. The rule says we round off.
The rule is always there. Let me check
Yeah,
it.
on our instructions.
The rules.
Unless they check otherwise.
Yeah, it is Barking. If necessary, round off answers to 2 decimal places unless they said otherwise. So you killed it. You got 68%.
Okay.
Out of the test, you got 68%.
Oh, part of the test. No? Okay. So I think we should have approached it this way, because it seems as if we approach it as if we're starting from scratch.
Yep.
So it shows which Lwandle has a basic understanding of what this trigonometry thing is all about. So we don't have to do question the first one. We can attempt the second one, or the other thing that we can do. Okay, yeah, let's do the second one, because the first one is already done. Or should we do it?
Let's move to the second one.
Let's move to the second.
Or
Okay.
maybe if Chad can tell us what to do if you understand the first question.
Let's go through it. Let's just touch on some of the things that are important there. Here the diagram is not given now.
Yeah.
So how did they know which one is a hypotenuse, which one is not a hypotenuse? The one. So let's go and read the instruction. It says
in the right angle triangle ABC angle.
In a right angle triangle ABC. So you have ABC, yeah.
Angle B is equal to.
That's why you need to start the one. You start with B, and then you say B is equal to 90, and then
it says side AB is equal to 8 centimeters.
So from there onwards, again from B, you can move anywhere. Then you can say I go this side, and then I go to AB.
Yeah.
So it's AB. As long as you started, you grounded your 19, and then they say this one is 8 centimeters.
Yep.
Okay, when we go up.
Okay, when we go up, they said again they said BC is 15 centimeters.
Yeah, so the other one, remember, we already have AP. Then when we go up, it means which we are going to have what? BC. Automatically, there's one person who's remaining, man, who is going to be opposite 19.
Yeah.
Who's that person?
The person he has no value.
It's hypotenuse.
Yeah, he's hypotenuse.
Yeah.
He has no
so that's how you draw it, guys. You always start from the 90 part, and then you can move from there onwards. I think that one, it's clear. Now, and then this one you start doing it as early as grade 7. If you are given 2 sides in a triangle, which is a right angle triangle, you can always get the third side by using the theorem of Pythagoras.
Yeah.
And then in this case, it means you are going to say that you have BC. So we're just highlighting, I guess we're not doing it.
Yeah.
We'll just say we have BC all squared.
BC all squared.
Yeah, which is going to be given by this one here, which is going to
AB all squared.
AB all squared plus
AC.
AC. So we start with the hypotenuse. Always start with the hypotenuse. BC all squared. Okay, sure. So that's how we're supposed to, in a nutshell, we're supposed to approach this question. The other thing that we then had to do was to determine the They said we should determine, I think it was sin angle.
AC.
Eh?
You should determine AC. First question says calculate the length
Of AC,
side
which is the
AC.
hypotenuse side. That one is fine. Okay?
Yeah.
I'm saying the next question we're supposed to do what?
Next question is saying you should calculate the magnitude of angle A.
Angle A. I thought we're supposed to get angle A. Now, angle A is the one that we're trying to define. That you say in relation to A, we want to check what is AB, what is BC, because AC we already know it's a hypotenuse side.
Yep.
The two remaining people, then you use the trig ratio, which is from Socraton. It's fine.
Okay, yeah.
Okay, we're trying to skip, guys, so that we don't bore you, because this one we saw when they killed it. So let's go to the next one then. Or do you want to take it again?
Oh, but then I think Ugari he did it. Ugari he did all of it. Let me check. Let me be sure.
He did the whole of
2.1. He did 2.1.
Yeah.
The whole of 2.1, and then he did 2.2.1, 2.2.2. Where I only did 2.1. Hey, wait. Let me check the question. It's 2.1, 2.1.1. He did 2.1.2. I think maybe this thing didn't check everything. London did 2.1, but then he didn't specify it's 2.1.1 and 2.1.2. He did 2.2.2, 2.2.3. He didn't say over the last one is 2.2.3. That's why he didn't get the full marks for question 2.
Okay.
London, you were supposed to say, like, okay, 2.1.1, it's that one you use theorem of Pythagoras, and then you were supposed to write 2.1.2, 2.2.1, 2.2.2, and then you were supposed to say, like, the last one is 2.2.3.
2.2.3.
Yeah.
Okay, so he did everything.
He did everything.
So what we can do then is just to play a quiz. If he has done everything, then we can just create a quiz first that we can attempt a multiple choice question just to emphasize some of these things. And then we've managed to train the API key again today so that it doesn't give us questions that are not in grade 10. We saw yesterday it gave us partially grade 11. So we made sure we train it again today. That is why you see that, guys, sometimes while we're busy with this thing up until maybe September, the latest, we'll be testing. Each and every day we'll be testing. And then you might find that you've been logged out sometimes as we are testing here. Because sometimes when we're busy trying to test here, it logs us automatically. Then the data needs to be deleted. So it's still a process, it's still a working process. But by September, we are hopeful with him. Once you log in by September, everything should be smooth.
Okay, yeah. So then I'm gonna generate a trigonometry. Lovely. Next time, Barkin, do the thing. Barkin, number everything according to its numbering system.
Yeah,
I think that's rule is there on the question.
On the instructions there.
Yeah, because just imagine if someone was marking us. If it was me, I was gonna write, okay, this one is 2.1.1, 2.1.2. Me marking you. I'm a friendly guy. Yeah, I'm a friendly guy though. And it says what did they say? Where's that part?
The what?
The one year number everything according to its numbering system. I wrote in legend. Okay, here's our quiz. We have our quiz now.
We have our quiz already. Okay, chat. You can see the quiz. What is the first question it do?
First question says point P, which is minus 3:4, lies on a Cartesian plane.
Point P?
Point P, which is minus 3 and 4.
Is minus 3.
Our x is minus 3, then our y is 4.
So it's a coordinate thing there.
Yeah.
We have x, which is minus 3. We have our y, which is 4.
Yeah.
Yeah.
Lies on a Cartesian plane.
Yeah.
Such that the terminal ray OP.
Yeah, OP, yeah.
Terminal ray OP forms an angle with the positive x-axis.
Sure.
Where O is the origin, 0 is to 0.
Okay, so we have a Cartesian plane. We can take this question and then try to do it that side. So we're going to try to digest the English that side.
This person he's always fighting. He's not friendly. He's not friendly, this guy. I don't know why he's always fighting like this. Why should we fight, brother?
Remember, guys, if you're practicing alone, it's not going to give us the same quiz. When I go there and ask for your own quiz, it's going to give you your own quiz. It's not as if all of us are going to get exactly the same quiz. It's going to give. In fact, if we finish this one and then we do another quiz, it's going to give us a different one. So that one should be noted. You can use it as many times as you want until you understand thoroughly. So what do you have?
Yeah, we have our question.
Okay.
I'm going to do a roughly Cartesian plane.
Yeah.
Says
O is the center.
Yeah, O is the
so we
center.
start with 0 is to 0. Yeah.
This is O.
Yeah. And then P, it's a point again.
P is a point.
They say which P is a point.
Or minus 3 and positive 4.
So where would we find this point, Ghana? Where would we find this arm, basically?
This
minus 3 and 4.
Okay, all everything is positive.
No, we want the 3 is what?
The 3 is negative.
So where would you find, where is X supposed to be negative?
It's this side, at the second quadrant, and also at the third quadrant.
So yeah, we want Y to be positive.
And then our positive is our Y is positive on the first quadrant and on the second.
Okay, so we have, okay,
It's gonna be somewhere here.
it's somewhere here no? On the second quadrant. No?
Yeah.
They can advise us. Have you done this one? I think it goes part and parcel. Get this one. This one is using an aid of a diagram to solve. No?
Yeah.
Can you just advise us if you've already done this one? But it's part of trigonometry. It's something that goes on. They all go hand in hand.
It's the first one. I think it's the first one of trigonometry. That's the first they teach in trigonometry.
Not necessarily.
Okay.
Yeah. Okay. So they say we have angle.
But can they said they said OP forms an angle theta.
Yeah, so we have an angle. So yeah, this angle is like what we're trying to say is this. You know, we have an angle that is measured from the x-axis, and then it's moving towards the hypotenuse side, and then it stops there. We call it theta.
Okay.
Yeah.
Theta.
Just check which one if they've already done something like this.
Yeah, he said yes, he have.
He has done. Okay. So now we know which the theta outside and the theta. Like you can take this theta and then just put it inside. They're exactly the same. They're exactly identical. For a reason that I can explain, but it's going to take a little bit while if I explain. Remember, with trigonometry, we have reducing angles. Your reducing angles, you have 0, you have 90, you have 180. So if I have 180 minus theta, so this thing here is like, if you look at this one, if I say, I got this one here is theta. Can you see this one?
Yep.
It's theta. This angle here, this piece here that I just showed you, this one here. You see this piece here again?
Yep.
I got it from here to here up until the hypotenuse side. We call that one theta.
Yep.
This one here, just this small one here, this one here is going to be defined as 180 degrees minus theta. And then this angle here can be reduced such that it's equivalent to theta, because remember 180 is a reducing angle.
Yeah.
Does that make sense?
Makes sense.
Okay, so we can just put the theta inside so that we don't have to worry about it. And then the other thing that learners should know about this thing here is that it creates something that we call a butterfly. You see a butterfly,
So,
which it's going to be perpendicular to the x-axis. It's always perpendicular to the x-axis. So the arm that you just draw now is always going to be perpendicular to the what? To the x-axis.
Yeah.
And then you can come and tell them then it here on your x-axis, which here it means which we have O up until we get here. This one here is going to be minus 3.
Okay. Oh, up until we get there.
Yeah, they didn't tell us what is that.
Yeah.
What it is.
Minus 3.
Okay. And then the vertical line, this vertical line here is the one which is going to be what? To be 4.
Okay, the vertical line is going to be 4.
Yeah, what do they want, one?
Wait. I think I did it incorrect. It's this one is minus 3, and then this one is 4. Yeah.
Yeah, so we have x is 3, minus 3 again.
Yeah.
Y is positive 4.
Yeah.
Okay, sure. So here they're also testing with Elena. Can Elena draw? Because remember, as you move on, you should be able to determine where you're going to draw your arm. So you should be able to know where you're going to draw your diagram. So how do you know where you're going to draw your diagram? You check the x and the y. That's the one that is going to define to you where are you supposed to draw it. Okay. Now with that being said, what are we looking for tonight?
It says we should determine the value of 5 cos of theta plus 3 tan of theta.
You should determine the value of
5 cos of theta
5 the cos of theta
plus 3 tan of theta.
plus 3 the tan of theta.
Yeah.
Okay, so we're supposed to determine the trigonometric ratios. Now, I didn't get an opportunity to explain it, but based on what Ran just showed me, he showed an understanding. He understands what are trig ratios.
Yeah.
So we're going to do exactly the same thing in relation to theta. You see theta. We said the theta outside and the theta inside the triangle, they're exactly equal.
Yeah.
So we're going to say in relation to the theta that is inside, we have people that are going to be adjacent. We have people that are going to be hypotenuse, and then we have people that are going to be opposite. But first, let's get the hypotenuse side. How do you get the hypotenuse side? X-axis and the y-axis are always perpendicular to each other. So you should just put 90 degrees here.
Okay. 90 degrees here.
Yeah. Where x and y meet, every time where x and y meets, it's always going to be 90 degrees. Then it makes this thing, the line that they just gave us, this one of OP, is going to be our hypotenuse side.
Yeah.
So we shouldn't worry about that one now. So theta has to talk about these two people, man, that we don't know. Now let's give it something here. Are you sure we didn't say anything about this thing?
Yeah.
Let's say it's PQ. in relation to theta, what should we say PQ is? Is it opposite or adjacent? Because that's the question that we need to ask.
In relation to PQ, in relation to PQ, it's opposite.
It's opposite. So we'll say with this one, it's opposite to theta.
Yeah.
So the opposite to theta is 4. Don't forget theta.
Yeah.
You can just write which is op theta.
Yeah.
Now the minus 3 in relation to theta, is it opposite or adjacent?
It's adjacent.
So the other one is adjacent to theta. So you can say it's at to theta. It's adjacent just to theta. That one is fine. What one has already done. We're going to use the theorem of Pythagoras to get this missing side, which is OP. Remember, theta, we have X and then we also have Y, but we don't have what? R. Because we are working on a Cartesian plane. On a Cartesian plane, we have something called R. So we're going to get that R, which is OP.
R squared is equal to?
Yeah, so we are going to tell with them OP squared is going to be equal to,
OP PQ squared.
Yeah, PQ squared, okay. So in that way, so what is O?
Is equal to OQ.
OQ, yeah.
OQ is minus 3.
So it's minus 3. You should put it minus 3 all squared.
All squared.
Plus
PQ is 4.
Plus PQ is 4 all squared. So if you have a casual calculator like me, you can do it.
Yeah.
You already know what is the answer. So I'm going to tell them what OP squared is going to be equal to 25.
And that's maths.
A mark that learners usually miss. Remember, if you put a square root has a plus and a minus.
Yeah.
So you should just put it with OP is going to be plus and a minus. Plus minus, if you say root here,
Minus 5.
yeah. Now, how to decide? If it's X and Y, you decide based on in which quadrant you are at. But for R is always positive. Then you're going to tell them what it therefore, because it is going to be 5. But you see, I started by telling them what is plus minus 5. Before I concluded which is the positive one. Why do I say that? It's because of R is always what? Positive.
Yeah.
But if it was X, I was supposed to check on which quadrant I will work in.
Yeah.
Okay, it's fine. Now let's go to our answer. We're supposed to determine the 5. They said what? 5?
5 cos of theta plus 3 tan of
5. Now let's define what is cos of theta. In definition here, Socrates. Yeah. Then they say define is
adjacent all of hypotenuse.
he wants someone who's adjacent.
Adjacent all of hypotenuse. So our adjacent is
Adjacent to theta. Let's go and check adjacent to theta. Who's adjacent?
minus 3.
It's minus 3. So it means we are going to say 5 open bracket again. Instead of this whole thing here, we're replacing it now.
Yeah.
So this whole thing here is going to be replaced by minus 3 again.
Minus 3.
All over.
All over then our hypotenuse it's
Who's our hypotenuse? It's 5. Positive
5
5.
that we just got here.
Close bracket again. Yeah. Next.
Close bracket, then we have plus
Plus
3.
3.
Then we're gonna look for tan now.
Yeah. Let's define 10. How do you define 10?
Tan of theta.
Definition of 10.
Tan of theta is opposite all of adjacent.
So we're looking for someone who's opposite to theta and someone who's adjacent to theta.
Yeah.
Who seems to be opposite to theta?
The one who's opposite to theta is 4.
It's 4, no? All over, who's adjacent?
And then the one who's adjacent is minus 3.
Minus 3, okay, sure. Then we can do the maths here again.
Yeah.
Beautiful maths. You can clearly see 5 and 5, they're going to divide each other there again. Yeah. If they divide each other, what are we left with?
Minus 3.
Minus 3.
Yeah, minus 3.
Okay. And then they are subtracting each other, and we're not multiplying here.
Yeah, we're multiplying.
So if you multiply, remember, here I said 5 multiplied by 5, like the 5.
Yeah, 5 will 5 get 4 multiply 4 all over minus 3. Then 3 will go with 3 and then left minus. And then this will might but
So we have
45 by
-3.
minus 1 it's minus 4.
So we have minus 3, minus 4. That's what we're saying.
Minus 3 minus 4, yeah.
So your answer is minus 7.
Yeah, my answer is minus 7.
Yo, your answer doesn't look convincing. You got it correct, guys.
Okay, so then let's check our thing there.
We have minus 7 there.
We have minus 7 is number B.
Number B. Okay. What time is it? Okay, guys, we can't finish the whole quiz, but you can log in and then we can create a quiz similar to this one, right?
Yeah.
And then just request daily dose of mathematics. I think now if you log in now, we're not going to delete you. We've done the hard part. So if you just sign up now and then you hire the daily dose of mathematics, we are going to see the test that we're creating now. You should find it there. And then tomorrow we'll continue with the test. You can submit the whole test when you're done. It's already there. It has already submitted it.
Yeah, and remember to invite your friends tomorrow.
Yeah, remember there's that thing in that app there.
Friends to join our live.
Yes.
Let's make the life interesting, you guys.
Okay.
So do I use my grandma on this one?
To guess it.
Yeah, to guess those ones.
No, we'll submit it. Like, I don't want to embarrass you. You know what? Yesterday your grandmother gave us.
I know my grandmother can wait sometime.
Yeah.
On this one is telling me, oh, okay, it must be.
Let's try to fix those ones who can't sign up, guys.
I think
see.
And what was
C
next?
again.
C again.
Yeah.
Was it C? Was it not B?
Oh, it was B.
It was B.
Yeah, it
B,
was
B,
C.
C, B, okay, B,
It was
D,
B.
C.
Say A.
Yeah.
Okay, you take A.
Good two out of 5.
So you got the first one and your grandmother.
Yeah, I got the first one and my grandma.
So guys, you can see it doesn't work this thing. You need to know the maths. If you think when you're just going to guess and then hopefully you will get it, it's going to chow you. This thing is not going to work.
Okay,
Yeah, just make sure that you log in and then you just show them again. It would help to request the tutor.
okay.
This is for the last time. I think, but we'll communicate if there's any changes. They will just communicate them. Today we're trying to fix the issue of that grade 10 shouldn't be assessed like a grade 11. Anything that is from grade 11 should not be there. So that is why we ended up having a problem.
Okay, it says request a tutor.
Yeah.
Then it's gonna fetch all available tutors.
Yeah.
Now, since I'm a learner of the daily dose, I can rate them 5 stars. Okay. 5 stars. Wait a minute. 5 stars.
Okay. So you can say I'm a good tutor, guys. Huh?
Yeah, he has 5 stars now. You can request, like, you can hire him, press hire, and then automatically it will connect you with the daily dose of mathematics.
Okay. So let's put the task, and then while we are putting the task, you can just play the goodbye song, and then they should find it there. I don't want us to forget one.
Okay, in the meantime, let me play the song.
Milani, grade 10, don't miss the mark. We see the groups from 10 to 20, keeping it sharp. Frequency is 6, don't just use the 10 or the 20. Calculate the midboard, that's where the wisdom is plenty. Upper plus lower, then divide option number 1, don't use the boundary. Midpoint is the key to unlock the treasury. Estimated, meanwhile, Utois. Midpoint times frequency, then sum it up, add it up. Divide by the total free little frequency will guide us through the maze. Now look at part B, where the median hides. Don't just choose the biggest frequency, that's where the error slides. Frequency 14 is big, but that's not the median location. We need the middle position for this statistical station. Total frequency is 40, divided by 2. The 20 hit position is waiting for you. Calculate a Q middle 6, then 20, then 32. That 20 student is in the 20-30 group. It's true. Estimated, meanwhile, Utois. Calculated. Midpoint times frequency, then sum it up, add it up. Divide by the total frequency. See, keep your head up. That's the mean mark. Remember the midpoint. Why Utois? Remember the total frequency, a Sunday. Remember the cumulative sum. No more misconceptions, grade 10, the work is made. Meanwhile, Utois, calculated. Midpoint times frequency, then sum it up, add it up. Divide by the total frequency, see, keep your head up. That's the mean mark, a Sunday. Let's find the middle, where the median stays. Cumulative frequency will guide us through the maze. Class dismissed, sharp. Grade 10, you got this. Azambege.
So here's your multiple choice question. You can go to Funda Flow, sign up as a learner, hide the daily dose of mathematics. Then you're gonna find it under your learners thing there. I submit. Then you'll choose a back in the teacher's tasks, then you'll find it there. Start our goodbyes.
Yes.
Okay.
Till we teach Anna tomorrow. As we finish that test, we're going to try to do it one by one tomorrow.
We're doing the task one by one.
Huh?
We're doing the task one by one.
Like, I mean, we'll
See a bonga for pulling through the lesson. Hope you caught that daily dose.